This is Algebra 2, Chapter 4, Section 1. Solutions to a quadratic equation. This is in your note packet from Chapter 4 with the same title. The solutions to a quadratic equation are the points at which the function intersects the x-axis. The solutions are referred to as zeros, roots, or x-intercepts. Number of solutions. From a quadratic equation, you can have a graph that either reflects two solutions, one solution, or no real solutions. A two-solution graph looks like this. You will notice that the line of the graph intersects the x-axis at only two places. A one-solution graph or quadratic equation would be graphed like this. You will notice here that the x-intercept is only once, or the line intersects the x-axis at only one point. No real solutions would look like this. You will notice here that our line only intersects the y-axis and does not intersect the x-axis at all. Solve by graphing. Next, we're going to find the solutions to each quadratic equation by graphing. First, our function of x equals x squared plus 2x minus 3. Here is my t-chart. I start with -4. I insert -4 into my x in my quadratic equation, and my y value would result into 5. And so forth. I plug in -3 for x, and my y would be 0. I plug in -2 for x and solve the equation, and my answer would be -3. And I plug in -1 for x and solve the equation, and my y value would be -4. Here's the graph for those numbers. You will notice that our line touches the x-axis or intersects the x-axis at two places. So therefore, we have two solutions. Our line intersects the x-axis at point -3, 0, and at 1, 0. So our solution for x would be -3 and 1, where the line intersects the x-axis. Number 2, we have the function of x equals -x squared minus 10x minus 25. Here's our t-chart for x and y. When I plug in -8 into our equation, my answer would be, or should be, -9. When we plug in -7 into the above equation, our y value would be -4. When we plug in -6 for x, our y value would be -1. And when we plug in -5 for x, our y value would be 0, and so forth. Now we graph it. You will notice that once I graph my x's and y's at the proper coordinate pairs, that my line only intersects or touches the x-axis at one point, -5, 0. Therefore, this quadratic equation has only one solution since it touches the x-axis at one point, -5, 0. Therefore, my solution to this graph or this quadratic equation would be x equals -5. Here is the last one on that page. It is the function of x equals x squared minus 6x plus 8. Here's my t-chart. I plug in my x values. My x value first is going to be 0. When I plug in 0 for x in the above equation, my y value or my answer should be 8. When I plug in 1 into the above equation, my y value should be 3. When I plug in 2 into the above equation, my y value should be 0. And when I plug in 3 into x in the above equation, my y value should be -1. So I go ahead and I graph those x and y's, or those coordinate pairs, and you'll notice that my line touches or intersects the x-axis at two different spots, at 2 and 0 and 4 and 0. At those points, those are my solutions. So where my x is where my line intersects the x-axis. So my solution would be x equals 2 and 4. Now I want you to try problems 4 through 7 on your own. Go ahead and pause this video, and when you're done solving those equations, go ahead and restart the video to check for your work. So I have the function of x equals negative x squared minus 11x minus 28. There you'll see my x and y tables. So this graph is a two-solution graph, and my line intersects the x-axis at points negative 7, 0, and negative 4, 0. So my solution is x equals negative 7 and negative 4. Here is number 5, the function of x equals x squared minus 9. There you'll see my x and y t-chart, and here is my graph with those points plugged in. So we have that the graph is reflecting a two-solution quadratic equation where my line intersects the x-axis at two different points, where negative 3 equals 0 is where my line first intersects the x-axis, and at 3 and 0 where my line intersects the x-axis for the second time. So my solution for that would be x equals negative 3 and 3. Where is the x value at which the line intersects the x-axis? Number 6, you have your function of x equals 2x squared plus 6x. You see the x and y t-chart, and once I plug in those numbers, I get my y values, and I graph those coordinate pairs. So I graph negative 4, x equals negative 4, where x equals negative 4, y would equal 8, so I graph that point, and so forth. So here is the line graph for that quadratic equation, and you see that this equation has two solutions. It intersects the x-axis at points negative 3 and 0, and at the origin of 0 and 0. So my solution to this graph, or this equation, would be x equals negative 3 and 0, because those are the x values at which my line intersects the x-axis. Here is our last one. We have function of x equals negative x squared plus 8x minus 17. There's our x and y t-chart. Once we input those solutions in and graph those coordinate pairs, you will see that this line graph does not intersect the x-axis at all. So therefore, it has no real solutions. Our solutions that would be empty or x equals 0. Now let's do a factoring refresher. Quadratic equations can be solved by factoring as well. Let's refresh our factoring skills. What is the greatest common factor, or GCF? It is the greatest factor that divides two numbers. To find the GCF of two numbers, list the prime numbers or prime factors of each number, multiply those factors by both numbers have in common. If there are no common prime factors, the GCF is 1. So let's look at our factoring refresher page for the first set, greatest common factor. We have, for number 1, 12k minus 18. So we want to see what numbers go into both 12 and 18. 1, 2, 3, and 6 go into both 12 and 18. So which one is the largest? Well, 6 is the biggest, so I guess that's our greatest common factor. Next, we're going to divide each element by 6. So an element is 12k and 18. Those are two separate elements because they're separated by a math sign, like addition or subtraction. So when we divide 12k by 6, we're going to get 2k, and we would divide negative 18 by 6, we're going to get negative 3. So we're going to put our 6, which is our greatest common factor, on the outside of our parentheses, and inside would be our resulting answers. So it'd be 6k times 2k minus 3. You can solve that, check your answer, and solve that by taking 6 times 2k, which would equal 12k, and then 6 times negative 3, which would equal negative 18, and check and make sure that that's your answer and that you did it right. Number 2, we have 40x to the 8th times y plus 64x to the 4th times y. We are going to see what numbers first go into our integers 40 and 64. We have 1, 2, 4, and 8 go into both 40 and 64. So what is the greatest common factor, or which one is largest? That would be 8. Okay. Next, we're going to see if x's and y's are in both elements. If so, what is the greatest common number of x's and y's? In our first one, our first element, 40x to the 8th, we have 8 x's, or x to the power of 8. Our next one, 64x to the 4th times y, we have 4 x's, or x to the 4th power. So therefore, our greatest common number of x's would be x to the 4th. Now we're going to take a look at our y's. We do have y's in both elements. In our first element, we have y to the first power. In our second element, we have y to the first power as well. So our greatest common number of y's is 1. So next we're going to divide each element by their greatest common factor, and that would be at 8x to the 4th times y. So when we divide 40x to the 8th to the y times y, we get by 8x to the 4th times y, we get 5x to the 4th power. When we divide 64x to the 4th times y, we get 8. So our answer would be 8x to the 4th y times 5x to the 4th plus 8. You can go ahead and solve that to check your work. Now I want you to try numbers 3 and 4 on your own. So pause this video and then you can restart it for the answers and check your work. Here is the work or the answers for number 3 and 4. You can go ahead and pause it here as well to make sure that you got the right answers. When factoring, always look for a greatest common factor first. With trinomials, 8x squared plus bx plus c, where a is equal to 1, is solved like this. So number 5 on your sheet of set 2, we have x squared plus 14x plus 45. So when solving this, we want to look at the factors of c first. In this case, we look at the 45. So factors of 45 include 1, 3, 5, and 9. Of those factors, which two numbers add up to equal b, or your b of x? That would be 5 plus 9 would equal 14. So we want to set up our binomial or our problem. So we set up our parentheses. We're going to have two different sets of parentheses, and we'll put, since our a is 1, we will just start off with putting our x values in the first element position of each of those parentheses. And since all of our elements in that equation are adding, we know that our math signs within those parentheses are addition signs. Then we want to input our greatest common factors that equal 14, which is 5 and 9. We can check our answer by using the FOIL method. Here is number 6, w squared minus 15w plus 26. So the greatest common factors of 26 that added up to 15 would be 13 and 2. But notice that we have a negative 15 and a positive 26. So we will have to make sure that we have two negative signs as our signs within our parentheses. So our answer is going to be x minus 13 times x minus 2. Next, I want you to practice numbers 17 through 12 on your own. Please make sure you check out the next slide for trinomials.